So the article on Facebook that I shared, copied from Internet Search Engine, states that oxygen is produced at the International Space Station by electrolysis. Now, what you do at the International Space Station has to be safe for fragile environment. So you will not do it like that on Earth. You don't have to. Now, the decomposition voltage is 1.23 to 2 volts DC. They use 2 volts because 1.23 is a theoretical number, but 2 volts give a better efficiency of conversion. Just from casual observation. Now, water doesn't break down just to hydrogen ion and oxygen ions. It has many other hydrates, crystals and hydrates, water formation and things like that, maybe within the water that you're carrying, carrying out electrolysis on. Now, if you're going to burn that hydrogen at 1 atmosphere, you don't have to store it. You just have to produce enough at 1 atmosphere. Now, the research into it is probably for space use, not for land use. Now, if that is true or reasonable, then I think that electrolysis can be done much more efficiently and faster at industrial scales. Now, hydrogen ions 2H plus combines to form hydrogen, essentially oversimplifying it. So you want to attract those as much as you can to that electrode where hydrogen is formed. And you want to do the same thing for oxygen. Well, the amount of South Pole attraction for the hydrogen ions could be less, much less than the amount of North Pole magnetic attraction for the oxygen ions because, well, actually, maybe the reverse. Because a lighter ion will feel more friction in the water. So the hydrogen ion side, you want greater south polarity to pull it there. On the oxygen side, you know, you want enough to get it there before it recombines. But maybe accelerating the travel to each electrode will be better. But to what extent? You have to find out the threshold. Now, if you circulate that water gently while it's happening, and if you keep that water warm while it's happening, and if you keep that water level sufficiently high at all times, but not to stifle the reaction, all of those things are important. Then you may end up producing hydrogen and oxygen very cheaply commercially, without catalysts, with magnets, electrical heating, and electrical actuation within the water to the level that it turns out to be favorable to producing hydrogen and oxygen consistently in the amount you want. Now, this hydrogen and oxygen we are producing is not for breathing or reconstitution in pharmacies. They are for fuel. If you need it for more pure than that, you can do other steps and purify it down water steps. You don't have to purify the one you're burning. You have to purify the one you're going to store, right?